We could ask, I will ask this question sometime else. If you are ready to start, then let's go ahead.
Sure. Okay. So I'm just muting everyone so that there's no disturbance on the line, and I'll ask some questions. So, okay. So yesterday we discussed few things. Let's do a little recap for them before we go ahead. So, guys, anyone want to answer why a block size is high in the system, or why I'm maintaining 64 MB of block size rather than traditional 512 bits kind of block sizes? Akash says faster seek time. Yes, that's one answer. And what could be the other? Okay, we have not covered the Mapreduce part. Sorry. Okay, that's perfectly fine. And low metadata size. Yes. Then we discussed there's something called task tracker. There's something called job tracker. What happens if the job tracker goes down? So in my system, if job tracker goes down, what could happen in my system? No one want to answer? Akash says job tracker on secondary name node becomes active. Now, Akash, job tracker is not associated to a name node or secondary name node. Job tracker is a separate process which could be running in your name node, but there is no such guarantee, or there is no such requirement, or there is no such mandate that it should be running on your name node. It's just a process which is running. This process needs to be ran on some. It should not be ran on some commodity hardware. It should be running on some Ferraris. And the job tracker, as a responsibility, take care of all the jobs which are running in the system. So it does all the bookkeeping of all the jobs which are running in the system, and it does all the management of all the jobs which are running in the system. So the secondary name node will only come in picture when my name node is down. As a name node, as a hardware goes down, job tracker is just a process which is running in my system, and that could be running in the name node, but there is no such mandatory thing. So what happens if some task tracker goes down? Kamalji says data node will send task. Sorry, Kamalji, could you please elaborate? Lohit says job tracker will send the task to another node. Yes, that's perfectly correct answer. Kamalji, I'm not able to get your point. What you were saying, though the completion will be a question mark. Completion will not be a question mark. That's a beauty in the system. Job tracker will take care of this thing. If it does not receive the heartbeat signal from the task tracker, it will assign those tasks which the task tracker was doing to some other data node where that replicated block is lying. So the job tracker will send a task to another node, yes. If it does not receive any heartbeat signal from a task tracker, and as job tracker is doing all the bookkeeping activities for all the jobs, so it knows which node is running which task has been done, which tasks are still pending or in a process state. So it knows everything about all your jobs which are running and the individual task of the job. So if some task tracker goes down, job tracker beautifully takes care of this thing transparent to you, and that assigns those tasks to some other data nodes. There are other frameworks in the system. I don't want to go in those complexities, but if there are things like we can set the failure sizes. We can basically number of times we can accept the failures, number of times the failed task could be re-triggered in the system. Then number of times failure task could be re-triggered in the system. Then what I was saying. If some blocks are faulty and task tracker is not able to run them, or the task tracker is giving errors for some particular blocks, so then job tracker will beautifully not send signals to run any process on those jobs to those data nodes. So it takes all those things at the back end. So there's a lot of things which happens at the back end, but I'm not going all these complexity on all these complexities right now. I will keep on talking once in between the sessions about these things. But for the time being, yes, that's perfectly correct answer. Abhijat says, sorry, I thought the question was what happens if the job trigger. So Abhijat, that was the first question. Then the next question was what happens if the task trigger goes down. Okay. Then we discussed about.
Miraj, I unmuted myself. Miraj, a quick understanding on this. I thought job tracker is at a higher level, whereas the task tracker is done at a data node level.
Yes, perfectly right.
So if the job tracker got failed, job tracker is responsible to collect all this information processed by various data nodes and getting this data or task completed. So who is compiling job tracker? If the job tracker is failed, then who is compiling this data?
So yeah, so that was that is what I asked in the first question. If job tracker is down, we can't do anything in the system. We have to reinitialize the job tracker or restart the job tracker. And although there is a way there's a configuration thing where we can define in the Hadoop 1.x that if job tracker goes down, this state is persistent. That is, it can reinitiate from the point where it's failed. But that does not work perfectly fine in Hadoop 1.x, and you would lose some of the information if your job tracker as a process goes down. And this has been beautifully handled in Hadoop 2.x architecture, or what we call yarn architecture. I will be talking about that thing when I'll be discussing about Hadoop 2.x yarn. But for time being, if the job tracker is down, the jobs which were being ran in the system, the state of these jobs, all the bookkeeping activities which were happening for those jobs by the job tracker are lost. So Abhijat, don't worry, I'll take care of that thing. I'll keep on pinging you. Don't worry, even if I don't receive the heartbeat signals from you, to ensure that all your blocks which I keep on sending to you are there in the correct state.
So Miraj, I just unmuted just to ask this. So
yeah.
If job tracker goes down and you are saying that there is nothing to take care, I mean in 1.x, right? In 2.x also there will be
in 2.x
there will be method to
yeah, go ahead.
So can you say that 1.x was not 100% reliable? Because of course for any system reliability is also a very key question, right? Before choosing.
Yes. So Rohit, as I'm saying, there's an configuration thing where we can ensure that job tracker is persisted at a timely interval, so that if it goes down, the state of job tracker is persisted. So if it in case it goes down, next time when it is up, it can take care of the state. I'll just mute you and I'll speak. So if it goes down, next time it goes up, it takes care of the state where it goes down. But that does not work perfectly fine, and there are some issues with 1.x like this. If your name node goes down and things like that, you could lose some milliseconds or microseconds of data, and same is the case with this job tracker going down, and if you reboot it or restart this process. But these things are beautifully taken care in 2.x architecture, that is the yarn architecture. So I won't say that the system is not reliable. System is reliable. People have a lot of productionized versions of 1.x also, but if something goes on, you might lose some seconds of data or some microseconds of the data. There is a probability of that. Does that make sense? I'll talk about how this is taken care in the yarn architecture. There's something called application manager rather than job tracker and task tracker, and that application manager is a manager for only a single individual job rather than taking care of all the jobs running in the system. And that makes the system more reliable, because if some application manager goes down, it's just the one job which goes down, and rest everything is fine in the system. Okay. So, and any other questions? If anyone has from the previous slides or from your last class before I go ahead. Hey Grish, welcome. We were just discussing about yesterday's thing. I just saw you on the attendees list. We were just discussing what.
Yeah. Hi. Thanks.
Mike. We were just discussing what we did yesterday, and we'll start with the new thing. So, any questions on anything which we discussed yesterday before I go ahead?
No, nothing more from my side.
Sure. Hi, Vijay.
Viraj, this is Abhijar.
Mike.
So, one really quick question. So, all of this looks to me, at least sounds so far, as a lot of system maintenance. A lot of machines, a lot of system maintenance, a sort of whole architecture to take care of, compared with our traditional Oracle database, where you just have to have a system with a lot of space and install Oracle and put the data in there and you're done. Is that the kind of trade-off we are dealing with here, to handle a lot of data efficiently and platform free, things like that? Is that the trade-off that we are dealing with? Because at the end of all this class, I'll be thinking about how to putting this in my office. So is that something I have to deal with, like putting a lot of commodity machines and
Abhijat, all you require is putting commodity machines and some Ferraris. Rest all this architecture takes care for you. So as you deal with Oracle, you put in the data and forget how the data is processed in the backend. All you have to do is just run the query, and Oracle will take care of the things. In some cases, you might have to index the table to make the query fast. Some cases you have to partition the table. Some cases you have to bucket the tables and things like that. Same way over here, you have to deal with the data. You have to think of how to store the data to make my Mapreduce things or make my data processing faster. Rest all at the back end is automatically taken care for you. You don't have to worry where your task tracker running, where your name node running, where your where your data node lying. Once the system is installed, the installation part is also not very troublesome, but that will be taken care by the admin people. So there could be some issues while the first installation of the whole cluster. But after that, everything is transparent to you. As a user, you will be running the queries as you were running in the Oracle. All these bookkeeping activities, these tasks are transparent to you. You don't have to worry about any of these things. I think this was your question, right? If I was not wrong. Yep, Abhijit says yes. Okay. So anyone else has any other question before I go ahead? Okay, no response. I assume that is no. So I'm just sharing my screen. Give me a sec. I hope you can see my screen. If not, just let me know. Anyone can just ping me if you can see my screen. Role says yes. Okay, I'll assume the same from others. So I have purposely moved back to this slide, and I'll just forward from this slide so that if you have any questions, you can just ask it over here. We did not discuss the input space. Don't worry, I'll be discussing what is split for a time being. Just assume it's equivalent to a block. So anything which comes to your mind or which pops to your mind from these slides, do let me know. I'm just purposely going from these slides. Okay, so I'll assume nothing from these slides, and we have already discussed the heartbeats and task tracker and job tracker. So now let's see how the really write happens in the system. I, as a client, sends a signal to a name node add block. Name node does not do anything. Name node does not waste its precious memory, precious resources in doing such kind of mundane tasks. Name node just returns the client. Go ahead and write these things to data node so and so. So as me as a HDFS client, I'll send a write signal to data node first, which is written by the name node, and the data node 1 will then send a write signal to data node 2. Data node 2 will then send a write signal to data node 3. Data node 3 will send an acknowledgement to data node 2. This to 1 and this to client, and then client will send just a complete signal to name node. So in this whole process, name node came in picture, and this whole process from here. In this whole process, name node came in picture only twice. Name node returned me the block, the place or the address where these blocks need to be parceled, and me as a client, I at the end of this whole process send a signal to name node that yeah, the blocks have been perfectly placed at their desired location. And that is the reason I was saying yesterday when I was talking in this slide that the first block, when it goes to some disk, and there the localization also comes in picture, then the second and third block goes to the same rack. And the reason behind that is the data transfer happens from this node to this node rather than this node to this node for the third copy. And that's the reason that the third block is placed locally on the rack where your second block was placed. And the first block, the position of the first block is chosen based on the locality of the client. If I as a client is sitting on disk 1, then there's a high probability that name node would return the first node as this one only. But depending on the other factors like disk availability over here, the memory or the processing power available on this disk and things like that, if this is free or not, name node might return some other disk also. And to which rack the data need to be gone, 6 or 7, all these things are decided at the backend by the name node. And we can change this strategy by changing the network topology in our system. So we can, so everything is configurable. We can put in the network topologies. Yes, so here we have 12 nodes. Do you wanted to ask any question? I'm not sure what you wanted to say. Okay. So that's the reason I was saying yesterday that that is copied to the same rack, and the reason now I hope you can understand the reason behind that. So now say while copying this data from data node, I send a write signal to data node 1, and with the signal I will also send the location second and third where second and third copies of this data need to be placed. Now while adding this second and while data node 1 is sending a write signal to data node 2 and 2 to 3, somewhere in between this goes red, this going down. what could happen? Abhijat asked a question, who tells disk 1 to put the replica in disk 6? Abhijat, name node me, when I say add block, name node returns me something like this. Go and add it to disk 1, disk 6 and disk 7. Me as a client, just name node will, when I say add block to name node will just return me these three things. Go and write it to disk 1, disk 6 and disk 7. I as a client will send a write signal to data node 1. This is data node 1. And to data node 1, other than the write signal, I'll be sending two more signals, that is go and copy paste these blocks to disk 6 and disk 7. This data node will send a write signal to data node 6, and also with the write signal it will send a signal to copy this block to disk 7. Disk 7 will get a write signal from disk 6 and will write this block to it, and when it sees there is no other thing in the pipeline, this whole data pipeline, it will send an acknowledgement to data node 6. Data node 6 will send an acknowledgement to data node 1, and data node 1 will send an acknowledgement to HDFS client, and HDFS client will then send an complete or acknowledgement signal to name node, and in this way name node knows that what I have given to this client to write this copy to data node 1, 6 and 7, as I was showing in the previous example, that whole process is completed, and this I can safely assume that the write has been completed, and name node updates his metadata that block X is lying at data node 1, data node 6 and data node 7. Okay, Avidas says understood, cool. So my question was, so in this process, say this data node goes down while writing to this data node. What could happen in such a scenario? Can anyone guess? Akash, there is nothing a rollback in the system. Okay. So if not any acknowledgement received by client, then rollback. So Akash, I'm just coming to that one. Just give me a minute. So anyway, any guesses if this data node goes down in this whole process? Okay. Let me explain, and Akash, this will explain your question also. So if this data node goes down, when this data node 1 will try to communicate with this data node, and if data node is down, it will send a write signal to next thing in the pipeline, that is data node 7. And then data node 7 will send an acknowledgement over here. This will send an acknowledgement to client, and client will send a write or partial complete to name node. Name node at a backend will take care of this thing that this data node is down. So, and one copy of this block is missing, and that need to be replicated in a system, and that will replicate in the system. So rollback kind of thing will not come in the picture, and everything happens for you transparently in the system. Now say, does that make sense to everyone? Akash says, will name node then take care of writing to the new? Yes. Only 2 copies written. Not two copies written. Rohit. The 2 copies are written, and the write signal will be triggered from the name node to any one of these nodes to write the 3rd copy, and the system will be maintained into its correct state with 3 copies. Okay, Rohit says okay, Akash says okay. I'll assume okay from others. So now say another complexity. I'll try to add. Abhijat has one more question. So for the 3rd copy, who sends the write signal to data node client, or so client name node will send a write signal either to this data node or either to this data node to copy or to make one more copy. I'll choose another color to make it visible. So name node sends a write signal to either this or this, where the data is correctly copied. Now let's add one more complexity over here. Rohit, not via client but directly to the data node. Okay. So let's say this data node is up again. I'll just clear this whole thing. Is there a shortcut to clear it, or shall I have to escape only? Okay. Now say, while copying this data from here to here and from here to here, say I was trying to copy, say data which I was trying to write was something like X, Y, Z. It has been copied to this data node. This block was copied, and block has this text, say X, Y, Z. Sorry, X, Y, Z. From here it was copied to this node X, Y, Z. But while doing a network transfer from this node to this node, some of the bits in this block got corrupted, and X becomes some junk character, something like this, and Y and Z. So X became some junk character due to some network problems, or there's some bits got lost in the network transfer, or things like that could happen. So what could happen in this scenario? How that thing could be taken care of in the system? Same before, the client will no, but Akash, my question is how this data node, because this data node has received the data. Now, as the data has been received, it will assume the data is right. It cannot say to the client that data is not copied. Data is copied. Practically, data is copied, but there were some network issues, or there were some issues somewhere in the copy paste or anywhere which corrupted some of the bytes in the data. But this data node does not know that it can safely it does not know that this data which is being copied over here is right or not. It assumes that the data which it was supposed to have is existing only X bars, Y, and Z. So Abhijat says, do the block sort of cross check what's been copied? I mean, do the data nodes cross-check the data after copying? Yes, Abhijat, I'm coming to the that's only the thing which I'm asking you people to think of how this thing could be achieved. So I'll talk about that thing in this slide, but let me explain you that part over here. So with the data, we don't only transfer the data, we also transfer something called checksum. And does anyone understand what is checksum? Akash says that. Akash, would you like to explain that? What is checksum? Yeah, for checking the data integrity. So checksum is nothing but is a kind of signature of a whole data. So while I'm transferring this block over the network, with the block on the header side or footer, or based on my whatsoever my protocol I'm using, I'll add some signature to this whole data. That signature would be some logic or some bits and bytes calculation on this data, and that will contain some value in bits and bytes. So that the signature for this block comes 10. So signature for this block comes 10. The signature for this block comes 10, and signature for this block comes 10. But at this point, when this data node will try to copy this data, it will again check or run that algorithm to calculate the checksum for this data. But as this data got corrupted, this checksum will not be 10. It might come 11 or it might come 9. It will not be 10 because this data is corrupted, and that could not happen. So in that case, data node will safely assume the data which has been copied over here is not correct. Yes, Aka. Sure. Okay. So This is how the data validity also taken care. Also at the backend, there are processes running at the backend, particular threads which are running, which are doing these tasks for data already lying on the data node. They do a timely check on all the blocks, whether the blocks have the correct checksum or not. If they feel or if they find that the checksum of the blocks is not correct, they assume that blocks have got corrupted. And in such a state, they send a signal to name node that so-and-so block on so-and-so data nodes have been corrupted. Name node at a backend, name node knows where the copy of those blocks are lying and where the perfect copy of those blocks are lying. So name node sends a write signal to the nodes which have the correct copy of those blocks, and then those blocks are copied from those nodes to some other node to maintain the replication factor of the system. And once that copy has been done, delete signal is sent to that node where the checksum was did not came correct for the block, and that block is deleted. The faulty block is deleted from the system. So Rohit, also that's an interesting question. And the checksum will never get corrupted. Checksum can also get corrupted. So say if the data XYZ came over here and the data XYZ only came over here rather than X bar, but checksum got corrupted and it became 11. So in that case, again, the data would be assumed as corrupted based on the algorithm to check the checksum, and it will send a signal that the data got corrupted, and then the data would again be copied by the mechanism which I just talked about. So there is a drawback, but the probability of checksum going corrupted is as high as data going corrupted. If the data got corrupted, the probability of the checksum also going corrupted is that much only. Because if some bits are changed over your block, then there's some problem with the network or something. And if the checksum got corrupted, there's a high probability that your data should have also got corrupted. So there is a drawback. We are adding some extra bits, but the added on hardware cost for this checksum is not even 1%. Abhijat says, is the checksum also stored on name node? No, Abhijat, checksums as displayed in this diagram, checksums are stored with the blocks only, with your data only, so that the timely checks on these blocks could be done. Name node do not store anything about the data, it just stores the metadata of the data, that is where the data is lying, what is the state of the data, and things like that. So Rohit, Abhijat, does it clear your doubts? Abhijat says, okay, else how will know what is the right checksum once the data was checked? So that's what I'm saying. Okay, just a minute. Let me clear the confusion. So Abhijat has a question which says, else how will if the data node contains does not store the checksum, how it goes to know that the data which has been copied is not corrupted and things like that. So I hope everyone can see my Excel sheet. So say this is data node 1, this is data node 6, and this is data node 7. I as a client sent a write signal to write some data, and data is say just 123. So this is my data which need to be copied. And checksum is nothing but just the sum of these digits, say for example. So that is 2 and 3, 5, 5 and 5, 10 and 15. So this is the checksum. So my block would be something like this. So this is a block which will be copied on data node 1, this is a block which will be copied on data node 2, and this is a block which will be copied on data node 3. And this is a block which has been sent from the client. When the data is copied from data node 1 or say data node 7, 5 became 7. So now when the data node 7, while copying this data, does the checksum validation, it sees the sum is not 15, the sum is 17. So it will assume this data is not correct. and says the data which has been supplied to this data node is not correct, and at the back end the same thing happens and it will be done for you. Now, as Rohit pointed out, can the checksum node got corrupted? Yes, definitely checksum can get corrupted. Say it becomes 16 and this remained 5. So in that case also data would be marked red only. But if checksum got corrupted, there's a high probability that there's some issue over the network or while copying or anything, and your data would have corrupted. The data state would definitely be could be 1, 2, 3, 4, 5, but the probability of that thing is less, and this is the trade-off that we have to bear with this checksum technology. Abhijat, does that make sense?
Biraj?
Yeah.
Okay, so back to that example. So if we not consider the case where data is being sent by the client, if we just consider the case where data is lying in 3 data nodes, and the validations are going on. Okay, so there are 3 data nodes with the same data, and the checksums are 10, 10, and 11. The data was sent 5 years ago, for example, whatever.
Yeah.
So if it is, how do we know which is the right one? After, like, right now I can check with the client and say that, okay, 11 is not 15, and so this is the wrong one. But when the data has already been sent, the data is lying in the network, and then suddenly one of the things get corrupted. There has to be a master copier. There has to be a master, information saved somewhere to say that, okay, if it is not 15, it is wrong.
Okay. I'll just come to the part. Okay. So me as a system, when I configure the system, I also have something called checksum logic, checksum algorithm. So my checksum algorithm says the checksum will always be the sum of the digits. So in this case, when the process, which is validation process, which is running at the back end, the thread which is running at the back end, what it does is it just do the sum of these digits and prints the output. So now when this 15 is validated with this 11, it marks it as red. So nowhere you have to store the master copy, things like that. That's the beauty about storing the checksum in the header. All you have to do is just validate the data with your header, and there's some mismatch between your data and the header. Your data is marked as corrupted. Make sense, Avijat? So the logic of computing checksum, it is also present in the header. No, logic of computing does not present in the header. We know what is the logic we have used to create the checksum, and the same logic would be used when we are doing the validation for the checksum. If we store the logic also with the data, we are increasing the block size. We are unnecessarily storing some extra data in our blocks and increasing the storage in our system. So there are many algorithms, open source algorithm for checksum. The default checksum algorithm which is used in Hadoop, but I'll just tell you. I'll not go into the checksum algorithm itself, but there are many open source checksum algorithms which could be defined in the system and could be used. So that is configured in your Hadoop cluster. That is again you can use the checksum algorithm which you want to use, and the algorithm could be configured in your system. By default, the algorithm is so right by default. This is algorithm which it uses CRC32. If you Google it, it's a cyclic redundancy check which does some cyclic redundancy. I am not perfectly sure what this whole algorithm is all about, but you can definitely read about this. So it's a kind of error detecting. So if you Google it out, This is an open source checksum technology which is used, cyclic redundancy check, which is a commonly used open source technology, and you can so that will be applied to all your data, and will be cross checked with the header. So just read it out if you're how this happens at the backend. I just given you an example of summing the digits, but the technology which is used could be anything. And the logic of that technology would definitely be there when you are configuring the checksum. What if you are changing the default checksum to something else. Okay, Abhijat says okay. Was there any other question? Kamaljeet, is this a part of HDFS? Sorry, Kamaljeet, what you were asking, what is a part of HDFS?
Is CRC32 as part of HDFS? Or that is a generic checksum?
That is a generic checksum used across the world. That is not a part of, that is not nowhere related to Hadoop or anything. That is a generic checksum technology, or I would say algorithm. So this is how the data validations happens in the system, and and at the backend also there are scheduled data validation which keep on happening in the cluster to maintain the integrity of the system. So this is I was talking about data pipelining. Client retrieve the list of data nodes on which place and all these things. I just talked about in the previous slide. Any questions over here? Okay. Now let's look about the read anatomy, how the read happens in the system. Again, the locality factor taken care while I'm reading the data. When I'm asking, if I have to read some file, I ask the name node, and I get the blocks. Name node will return me the blocks of those files. Name node will try to return, will take care of the locality or the network distance from the client for those blocks. So if there's a nearby block, it will try to return those nearby blocks to the client rather than sending the block address of some remote data center or remote rack. And name node returns me a list of blocks, and I as a client can go and connect to those data nodes and read the data. So I'll keep on reading the data for that file, and this is how the read happens. How does the name node know the distance of the network? So when you configure a system, you also configure the network topologies, like which are the racks in your system, which are the data nodes in that rack, what is the network bandwidth between the rack, what is the network bandwidth between your data nodes, what is the network bandwidth between your data centers. So based on those things, name node can do a calculation. What is the fastest network between HDFS client and the data node? So if I have to travel from New Delhi to Agra, I can either use expressway. I can either use a route passing from in between Meerut or something. Both are perfectly fine. But I, as a client, knows which is the fastest route, and I'll take that. So okay, Rohit says okay. So this is I was just discussing in the previous slide to check the data correctness, and I've just discussed all these things. So it's using the checksum algorithm, and these all things are created and checked. Any questions on anything? This is all from this slide. Any questions which you want to discuss? Anything you want to discuss in Hadoop basics before I move on to the Mapreduce world? Okay, sure. Let me move on to the next slide then. So before moving to this slide, let me show you the real system, and then we'll be looking into the Mapreduce world. And before showing the main system, let me talk about. So I hope everyone has received an email now for the softwares which I have shared with the people. You just download these softwares. Don't worry about installing them right over. You can install it in your free time over the weekdays. But let me just let me know if you have not received the share drive location over your email address. If not, I'll get that thing done. So let me talk about those softwares, and then I'll come back over here. So this is a folder which I've shared with everyone. This folder has a few things. Those who are not from the Java background, do let me know wherever you are not able to understand it. I have shared some of the Java related things also, which will be working, which will be used in running the Mapreduce code. So I just request you to at least try to run at least one Mapreduce code. That will give you a confidence of understanding the Mapreduce technology, and that will also be helpful for you. And that could be helpful for you anywhere in the life, and that will also help you understanding the other technologies like Hive and Pig also. So I just request you to try to run at least one. Do not write any code. Use all the pre-compiled thing which I'll be sharing with you, but try to run at least one. So what I've shared is inside the software folder there is something called VMs. Inside VM I've shared a virtual box. So if you install this exe, it will open something like this. Well, after installation, let me share my screen because. So after installation, it will look something like this. Then what you have to do is download this OVA file. This OVA file is I think 2 GB or something. This is Hadoop 2.1, Hortonworks 2.1 version. This is the latest version 2.2. I'll share that thing also with you people also. But 2.1 is also good enough for the example which I'll be talking about. So once you download this OVA file and keep it somewhere in your C drive or E drive or XYZ drive, and once your Oracle VirtualBox has been installed, click on File and click on Import Appliances. It will open something like this. Click on Browse and browse that OVA file and press Open and press Next, and once you press Next, something like this will appear, Hortonworks Sandbox 2.0. All you have to do is right click and start it. Once you start, it will start something like this, a black box, and it will start at the back end lot of software which are already configured in this VM. So this VM has configured all the software which are required to run this Hadoop, to run a single node Hadoop cluster. So this will be a single node Hadoop cluster which will be running on your laptops, and that will consume a lot of your RAM. So please ensure that you have at least 4+ GB RAM in your laptops. If you don't have, I request you to just get it increased. Bare minimum 4 GB is required. Otherwise your laptop will become very slow. So when you click on start, it will start something like this. It will start all the things which are required for this, all this magic which I was talking till now, which are required to be happen in the backend. So there are many things which come in picture for all this thing which I was talking about till now. To run the backend. So other than this, there are a lot of other components which are there in the system. So all those components are installed on this single node. The name node and data node are same over here, but practically in the larger cluster that would not be same. But for running the examples, we will be using it. The real cluster would be exactly same. Only the difference is here you know that you are running a single node, but in the real cluster also you'll be communicating in the same way as I'll be showing you right now. There will be no difference in any of the command. There will be no difference in how you connect to the cluster. You'll be connecting to any of the data node in the cluster and running the same commands. Only the difference is right now we are just virtualizing the environment on in our local laptop. In the real cluster, you will be connecting to the to some other IP, which is one of the data node of your cluster. Rohit, will 3 GB work? So I hope your laptop is started to bit. It won't work. I won't say it won't work. So anything can fit in, but try it out if you are okay with that speed of your laptop. I have no issues, but 3 GB will also work. You can at least open it up. You can at least start it up, but that will slow your laptop a lot. That's all I was saying. HDD space requirement, Kamalji, this 2.0 is 2.1 GB. 2.2 is somewhere around 5.5 GB. I've shared 2.0 only because lesser in size. And after opening it up, after adding it to Oracle VM box, it might increase to 3 GB or something. Nothing else on the hardest side which is required. Okay, so it will take some time to start up, and once it's started, what you have to do is inside the software folder there's something called putty.exe. Anyone who does not know what is putty, I'll explain it right away. Anyone who does not know what is putty or what is WinSCP? Okay, Kamalji says what is putty, Girish says I don't know, Abhijit says what is WinSCP. Okay, so guys, these are just utilities which help you to do SSH to your server. So putty, with the help of putty, will be able to communicate this box, or when you are communicating to the cluster, also you will be using something like putty. You can use any other versions, but you would use something like putty to do a SSH communication to your cluster. And WinSCP is nothing, is a kind of file transfer protocol, which will be as a file transfer utility. So you will be connecting to this sandbox with this help of WinSCP to transfer the files. So these two utilities will be keep on using to transfer the code which we have written and to communicate with the sandbox. And same way, when you are running or working on the real cluster, you might be using the same things. Only the thing what you will do in that case, you'll be communicating to any one of the data nodes in the cluster. So let me show you and open these putty and WinSCP. Just download them. No installation is required. Once you download them, just double click them. So when you double click your putty.exe, it will open something like this. Just a minute. So it will open something like this. This is another version of putty. This is Kitty, but the right hand side of your putty would look something like this. So to connect to this sandbox, which is starting at the back end for me, okay, started. What I have to do is I have to print an IP address. So this sandbox is listening on 127.0.0.1. Beware, when you bring your mouse on this sandbox, mouse will disappear. So don't worry about anything has happened to your system. Just move your mouse out of this box area and that will appear for you. So all you have to do is communicate to this box on this IP address, that is localhost 127.0.0.1, and the port as mentioned over here is 2222, not 22. So just change the port and press OK. And once you press OK, there is an SSH connection made to this box. It will ask you for a login, user ID and password. User over here, the default user is Hugh, H-U-U-U, and password is H-A-D-O-O-P Hadoop. I'll ping that thing on the chat window. It's Hugh/Hadoop. Everything in small. So now I'm connected to this virtualized environment on the which is running on the Windows. Same way, when you are communicating with your cluster, you'll be entering an IP address to some particular node of your cluster. It could be any data node, it could be any name node or anything. Once you're connected to that, that would be a Unix Solaris or some kind of box, and you can run this normal Unix Solaris commands. Now let's look into the HDFS word of this thing, what we are talking till now. So when you have to interact with the HDFS file system, our command will start something like Hadoop and FS. So this Hadoop FS tells that I am communicating with the Hadoop based file system. And if you don't remember the syntax further than Hadoop FS, what you have to run, what you have to do is just press enter, and it will give you all the help, all the commands which are feasible or possible with Hadoop FS. So if I have to look into Hadoop file system, I'll just say Hadoop FS minus ls root. So I'm looking into the directories which are lying at root location of Hadoop file system. So this is a normal Unix, your Linux command ls. I hope everyone understand what is ls. There's a list or directories at a particular location. So, but I have prefixed this command with Hadoop FS. So now this is a Hadoop FS command, and this ls has been passed as a parameter to Hadoop FS command. And here I am listing the directories lying into the Hadoop word, not into the Unix word. If I say ls root, now I am printing the directories of the root of my Linux system on which I am logged in right now. The client which I was talking till now. So this is the client where I'm sitting, and this client is localized on data node 1 because I'm connected to data node 1 in my system. But this is a single node cluster, so name node and everything is there. But if those are in a bigger cluster, so all the localization factors which I was talking to you till now would have been taken care, and the network topologies and things like that. So is it making sense till now? Are you able to follow up? A quick yes or no will help me. Akash says yes. Kamalji says yes. Girish also says yes. Okay, sure. So let's go ahead. So there are different commands to communicate with the Hadoop file system. Hadoop FS minus cat will get any file in the file system. So let's there will be a file called user u. So this is a file which is there in the Hadoop file system. I know about this file. So what I did is I pressed a command called Hadoop fs minus cat. Cat is nothing but to print your file. So Hadoop fs minus cat and then the text file name. So this prints the file for me. Now I want someone to answer what happened at the back end, how the communication happened at the back end, and how I am able to get this file on my console. Do anyone want to answer that? We have just discussed all these things, right topology, read topologies, and things like that. Akash says and the client. Okay. Akash says the name node tells the client where the file is, and the client reads it from the data node. Yes, Akash, but the client name node will return the blocks. So there could be 20 blocks in the file, and those 20 blocks would be segregated across data nodes, and client will go and read one by one from those data nodes. Kamalji says is task that got it. So Kamalji, this is not a task which got executed. This is just a read which happened in the system. There is no task which you have triggered till now. We have just triggered a read from our file system. The read topology which I was talking previous in my last slide, I think. So we'll be running the task pretty soon. Don't worry about that part. So this is how I can interact with the Hadoop-based file system. Now, if I have to put some file, I can just say put. Let me look at some local file. Okay, there is something called estimate parcel.java. So let's see Hadoop fs minus put and put estimate parcel.java to /temp of HDFS file system. So this is a local path This is an HDFS path. I'm putting some file from local system to Hadoop world. So now anyone want to explain what happens at the backend? So the right topology which we are discussing, and the client sends the request to name node. Yes, client sends the request to name node. Name node will return you the addresses where the copies of this file need to be copied, and I as a client will go and start copying those blocks to the corresponding data node. So although there's a complex things which happen at the back end, the checksums and all those things, but all these things are transparent to you. You don't have to worry about any of these things. You as a user, you as a client have to run just some commands or have to interact with the system somehow to make all these things happen. The system will take care of rest of the things. So I think Kamaljeet or Abhijat had that question about how comparing it with Oracle or something. So I really forgot who had that question. So does that make sense now? So Akash, the question is there a way to know where the file is written, which nodes? Okay. Akash, to be very frank, I have personally not tried to looking at the block locations, but there would be definitely a way. I can figure that out and let you know in the next class. So actually this is all related to admin part, and I am not much related to admin related things, so I never tried these kind of things. I always try to run the programs and things like that. So I can definitely cross check that thing and let you know in the next class. There would definitely be a way to look into the blocks and how many blocks are there and things like that. Okay, so this is one of the way how we interact with the Hadoop based file system. And if I say Hadoop FS, this will give me all the commands which are possible with this. I hope you just understand what is cat. So since here's the command for checksum also. I can check the checksum also. Copy, put, make dir, tail, all those things, touch, delete, remove directory, move, put, move to local and move to copy are similar to what we have done right now, put and get. So put and get are another form of this move from local and move to local. So just try out these commands at your backend, at your on end, once you are able to install the thing which I've talked till now. So I've just opened the PuTTY and installed the Oracle VM VirtualBox and imported the OVF file, started it and double click the putty.exe. Started it on 127.0.0.1 on port 2222, and I use the user ID as Hugh and password as Hadoop. And this window is open for me, and here from this window I am interacting with the single node cluster, that is the sandbox which I have configured on my laptop. And what is a snapshot? Akash, you are talking about yeah, Rohit, if you want to virtualize it on rather than Oracle or some VM virtualization or something, I share you the link. You can directly download the other format from there, and you can virtualize it with the help of that. Here I've downloaded the OVA for Oracle VirtualBox. You can use the VMware VirtualBox also, and can use it. So if you want for VMware, I'll share the link. You can download it. But Hortonworks suggests to use Oracle VirtualBox. So I'm using Oracle VirtualBox. Just give me a sec. I'll be back in a sec. Hi. Sorry. So actually, in the societies there are prepaid meters, and if your meter balance falls a particular limit, it starts making irritating noise. So it was just making irritating noise, so I just stopped it. So Rohit, does that make sense? I'll share that. Akash says minus rename snapshot, snapshot di, old name, new name. Rename snapshot. This rename snapshot. Okay, Akash says what is a snapshot? Okay, so I hope you are talking about this snapshot. You are talking about this OVA file, or you are talking about what was displayed over. Sorry, over here. Akash, I'll just put on air. I am not able to get your point. Might be if you can speak, I'll let you know.
So basically on the Hadoop file system, right? Hadoop FS, there is a parameter there, rename snapshot. If you go back to your Hadoop,
Okay.
yeah. So I just quickly browsed through all the commands there, and it makes sense apart from this one here.
Okay. Create a snapshot. So wherever you don't know, just print the help. It will. So there are a lot of commands. So what I personally do is I'll just check the help. Create a snapshot, delete a snapshot. I have not used. I'll just check it out. Also, I am also not sure. The best way is I just try to Google it out, or I can just look into the help over here. So this snapshot is again an admin related thing, so I did not use it. So this would be probably related to okay. We are creating a snapshot of a directory. So we can give a path to this command and create a snapshot of that particular path for you. And delete a snapshot is, I think, it's just a reverse of create a snapshot. That will delete that snapshot which you have created in the previous command. So this would be required if you are doing something like doing some testing, or doing something on the particular blocks or some particular files. Then you can create a snapshot of that, work on that, and then delete that snapshot later on. Okay, so there are other commands also supported with the Hadoop. If FS and there are others, I'll talk about them. So there's something called ZAR. This is a command which we're using to submit our jobs, which Kamaljeet was asking in previously. So here, how to run a job is you have to say Hadoop jar and give your ZAR file or the logic which you want to run. So there will be some ZAR file. Yeah. And some parameter to the ZAR, what need to be read and where an output need to be produced, and this will trigger the real job which I was talking in my job and the job tag and the task tracker. As a backup related thing, probably not, Rohit. I'll just cross check in a minute. I'll just give me 5-10 minutes in the break time. I'll just cross check that thing. That probably not a backup related thing. I'll just cross check that that thing for you. There might be some commands which I also personally would not have used them, because there was a lot of thing in this word, and but I'll definitely try to find out or figure out those things. So I'll just check those two things, the block related question and this thing. I'll just give me 5-10 minutes. I'll cross check the part. So this is the way I can trigger or submit a job in my Hadoop cluster. Now let's look into the so once you open it up, then there's one more way which I'll just show you. With the Hortonworks UI, there's something called Hue browser. So there's another way to look into the Hadoop file system. So if you on your laptop, once you start this sandbox, and is it started? Yeah, it started. So once you start your sandbox, and if you enter 127.0.0.1 and port 8000, something like this UI would be visible to you. And with the help of this UI, also you can browse your Hadoop cluster. So first time when you will be opening this address on your laptop, it might ask you to fill some form. Just fill that form. That is a one-time activity, and after that you will be able to sign into the sandbox. After that, it will ask you for the username and password. It's by default embedded in my Chrome history, so it has not asked me. The default username for this browser is Hue, and password is written on the same screen where it will be asking for the password. Somewhere on the top, there will be written the default password. Use that password, and you will be able to log into this UI. So over here, there are different things. So these are the different things which are running in our cluster. We'll be talking about them as soon as we are going ahead in the session. And they are dedicated UI for running the pig query. Here I can submit the pig jobs. Here I can submit the Hive jobs. Here I can submit the pig jobs. We'll be doing all these things on the console line also. But this is a UI from where we can also do. This is the ease of functionality. Edge catalog I'll talk about in detail when I'm talking about Hive. So this is a metadata about Hive tables. File browser is a real browser from where I can access the Hadoop-based file system. So here, if you remember over here, when I was looking into the Hadoop-based file system and I did ls on the root directory, these were the directories which were listed. So it's now this is a beautiful way to browse the Hadoop-based file system. And see, this is a file which I've copied into the temp directory. This is available over here now. I can browse the file system. I can do other things on the file system also. If I want to delete some file, I can directly call delete forever, delete move to trash. I can change the permissions, I can copy it, I can move it, I can rename it. So all the things which are possible from that from those Hadoop FS command are almost feasible over here. More than that, there's one beautiful thing over here. You can create new files, you can create new directories, you can even upload the files locally from your Windows machine direct to your HDFS with the help of this UI. So when I say file and select files, and I can just select any file and open it, and okay, this file already exists over here. So upload files, I just select the file, and this file is uploaded for me. So from my Windows system is directly uploaded to your HDFS file system. So for development purpose and for smaller size, this is pretty useful and useful for play with the system. But for bigger files, you will not be doing it like this. So Akash says, can you submit a job or jar for this UI? Can you submit a jar from? Okay, can you submit a job from this UI? Okay, so you cannot submit the job from this UI, but you can look into the jobs which are running into the system from the job browser UI. There is a there's a way you can interact with the system with the help of shell console over here. So in this UI, the same shell console is available to you. So from here you can submit the job, but directly put the jar and trigger it. There's a different UI for administration purpose. Rohit, I'll show you. There's an Ambari console which is used for maintenance of the administration or doing the administration of the system. This is majorly for the development and interacting with the Hadoop file system. There's a different UI separately, Ambari, which looks into this, which looks into the. So these are different flavors of shell. Nothing. These are different flavors of shell only. The bash shell, a HBase shell. HBase, okay. HBase is a NoSQL database, which uses HDFS as a backend to store its data. So I will not be talking about HBase in any of our sessions, but if you want, this is a NoSQL database. So rather than traditional databases, there are other database flavors in the market these days which are pretty high in demand because of different features which they make available to them. I hope you would have heard for HBase or Cassandra or MongoDB or Giraffe, which is a graph-based database used by Facebook. And things like that. So this HBase is one of the database which is integrated in this sandbox. This is a NoSQL database. So this is a shell for interacting with that. This is a pig shell, pig grunt. So I'll talk about this pig shell when I'm discussing the pig. Then this is a user admin. Here I can manage the users for this Hue UI. I can add user, delete user, give permissions to the user and things like that. And so as so Kamalji, as I said, the HBase shell is to interact with your HBase, that is HBase database. So that is a console for interacting with the HBase database. Okay, Kamalji, you got it. Okay. So as someone raised a question in between, is this administration UI? No, administration UI is something else. Android or ND. Okay. Someone might have attended. Okay, someone joined from phone probably. So there is a separate UI. Let me talk about that. Someone has raised it. So that is there's an Ambari UI which is used for cluster management or administration purpose. The default user, so the port on which you can log into this UI is 8080, and the username and password is admin for this sandbox. So this is for administration purpose. From here you can browse the whole cluster. So see here, I can see all the processes which are running in my system. I can go over here. I can look into the so I can stop the process. I can stop all the processes at a time. I can start all the processes and things like that. I can change the configuration parameter. So here are the configuration parameters about HDFS. Otherwise, if the parameter is not defined, the default one are loaded. So the parameters we are talking till now, these all parameters are defined over here. If you can't see them, then the default one are being considered. I'll talk about them in little bit more detail as soon as we are seeing some issues in the system or things like that. But this is all related to admin part of Hadoop. Same way you can look into Yarn is what we'll be talking about, that is Hadoop 2.x. So practically you will be running all your jobs in Hadoop 2.x, and that does not make any difference while you're running it 1.x or 2.x. It's the architecture which has changed at the backend. And here I can look into the different data nodes in my cluster. So as there's a single node cluster, there's only one data node which is visible to you. If it would have been a 10 node cluster, 10 nodes would be visible to you over here. And the processes which are running on this data node are visible over here. So these are different clients which this data node is running to interact with different servers or different things in the cluster. Don't go in all these complexities. I'll be slowly introducing these complexities to you. If I tell everything on the in one of the class, everything will just bounce back. So we'll again come back to this UI in some later point in future, but just showing you this thing. So I hope I've got some admin. Are you running the name node on normal machine? So Rohit, this is a single node cluster which I am running right now, which I've shared with you people. So name node, data node, everything is same in this cluster. Job tracker, task tracker, everything is running on the same machine, but practically they will be running separately. But the way you will be interacting with the system would remain same, irrespective of the fact how big your cluster is or how small your cluster is, even if it is a single node cluster. So this machine is just for your development purpose, for your playing with Hadoop related commands, submitting a job, getting the real feel of the system. But practically, when you're running on some productionized versions in your organization, you'll be interacting with the system in a similar way. Your commands will remain same. Only the thing which will differ is the number of data nodes which will appear over here, and then will change. The name node and all those things will appear over here. That will change. I'll show you a real productionized real production cluster also in one of my class, and we'll tell you that that the way we are triggering the command over here and the way we are triggering the command over here will not change. It's just it's all transparent to you. You just connect with anyone, anything, any node of the cluster, and rest all works fine for you. Akash, Hadoop FS command is it relevant only to Hortonworks? No. What I'm talking about is this Hadoop, Apache Hadoop, which is an open source, and all these commands will run irrespective of the fact of which flavor of Hadoop you're using. The way you are submitting jobs, the way you are creating a Mapreduce program, which we will be discussing it, is irrespective of the flavor of Hadoop which you are using. Nothing will change. Probably the directory structure in those flavors would change, but the commands, the way you are running the program, the way you are coding the programs would not change. Okay, so we have talked about two ways to interact with the Hadoop-based file system. One is from the command line UI, and another one is from this beautiful Hue UI. Let's talk about third thing, how I can interact with Hadoop file system before moving to the Mapreduce world. So so we have just seen these commands. This is the one way we interact with Hadoop file system. Hadoop FS make directory, list directory, list directory recursive, put a file, get a file, and things like that. Then another way is to interact with the Hadoop-based file system is we can use a package in Java called Hadoop FS, which is available in the open source JARs, and we can interact with it. If you want, I'll explain the Java program also, but looking at this class, I think probably none of you are from the Java background. So I'll just quickly go through this Java program. Let's take a quick 10 minutes break. It's 8:25 in my watch. Meet at 8:35 IST, and then let's go through this program, and then we'll be moving into the real Mapreduce world. Fine. Okay, Akash is sure. And in the meanwhile, I'll also check the answer for the question which you were asking it, exactly how that snapshot works. Akash is HDFS snapshot are read only point in the time of copies. Oh, okay. Okay. Yeah, I think yeah. I've used it also. Yes, you are right, Akash. We have used it also at one time when we were migrating from 2.1 to 2.2 Hadoop. We have used this snapshot. I forgot this thing. Yes, we have used it. We have migrated our production cluster from 2.1 to 2.2, and at that time, yeah, probably I think we have used this. I might have forgot it. Sure. Thanks for that, Akash. Yeah, I forgot the thing. We have used it also. Now I can recall that. Sure. Then let's take a quick break and let's meet after 10 minutes. I'm just muting my mic. I am back. So Akash is there, Girish is there. Kamalji says back, Avijay says back, so I think everyone is back. Okay, I'll just share my screen. Give me a sec. Okay. Sorry. So Akash, I was just looking into that thing also. Other than that, that snapshot. Now I can recall what we did with the snapshot, and also I was just reading about that also. So that snapshot helps you in maintaining the backup of the system, and that snapshot does not take any memory. When there are some changes in the file, then that snapshot will just capture the changes. And this way you can figure out the changes done to a particular file or to a particular directories or to a cluster, and can while you are doing some maintenance jobs and things like that. So, and someone was asking me if I can look into the blocks. So there is a command called HDFS FSCK. FSCK is used to check your blocks, and what I was talking just now, to check the correctness of the blocks and the validity of the blocks. So that is what could be used for doing that thing. So here I was just running that. So I just say Hadoop FSCK, I give a file name and minus blocks. So it just checks the validity of all the blocks which are there. So it says target replica is 3 but found 1 because we are on a single node cluster. And the blocks, there's only one block for this file and the state of this block. So let me go back to the PPT. So keep on asking me question. I might not be knowing the answer of all the things, but I'll definitely try my best to find out the answer for you. So this is the way we can. This is the third way how we can interact with the HDFS file system. We can use the Java utility, which is available for us to interacting with the Hadoop-based file system, and we can interact with the Hadoop-based file system from the Java code. So here I am creating a configuration object which I'll be requiring to get an pointer to the Hadoop-based file system, and from this configuration object, with the help of this configuration object, I've got a pointer or handler to my HDFS file system. And the same configuration can give me a handle to my local file system also. All I have to do is get local or get. So these are the two ways I can get a handle of my file system, the local or the remote file system. And when I get these handles, all I have to do is from these handles I can directly access my file system. So in this example, what I'm doing is I'm giving this program two inputs. One is the place from where to read, and one is the place where to write. The place where to read is a local directory that is locally on my Linux box, and this path is the remote or HDFS directory. So what I'm doing is I'm reading all the files at this path in my local directory, merging them into a single file and printing them to HDFS in this example. So here these are two handlers which I've got. One is one is HDFS handler, one is local handler, and I've got two directories: input directory, that is a local input directory, and this is HDFS file where I'll be outputting all the files in the input directory and merging them to a single file. So what I say is local.get all the files in the local directory, and I'm creating a file in HDFS at this location which I've given over here. Then I'm looping to all the files which are there in my local directory in this loop, for loop, and I'm reading those files one by one with the help of some input reader or local input reader, and outputting that to the Hadoop based file system. So this out is this output stream which I've created on that file system, and this input is the input files. So I'm looping on these input files, and I'm printing the bytes which are read from these input files to that output stream, and the file would be created in the Hadoop based file system, which will contain all these files which are lying in this directory. So this is another way how I can interact with the Hadoop based file system. Now let me try to run this Hadoop job, and that will be the real job, how we submit the jobs. So to run this programs and to change any of these programs before going over there, let me share a few more things. Do let me know wherever you think I'm going too much technical, I'm going too much inside Java, I'm going too much inside code. Do let me know. I'll try to explain those things, or we can escape if required those things. But do let me know wherever it does not make sense to you.
So Miraj, I know you are using Java all over, but is it possible to use .NET or even COBOL also to use Hadoop?
Good question. So Mapreduce can be written in Java, but when we'll be looking about Hadoop streaming or Hive and Pig, those are native technologies, but they also have things like UDF. You can create a user-defined functions in those languages. Those can be written in any scripting language like your R, or like your this thing, what do you call this, Ruby, or any other Python, any other scripting languages. But Mapreduce can be written in Java.
Okay. So I mean, Hadoop is not integrable with all the platforms. It is for new age systems like Java, .NET, or Windows platform, or Sun machines. Can it integrate with the old systems like mainframes or something? I know mainframes themselves are very robust actually, and their existing database system DB2 and all is very, I mean, efficient in terms of. But here we are talking about, I mean, explosion of data, right? So explosion of data, even mainframe also cannot handle that efficiently.
So Rohit, could you rephrase it? So what exactly you mean by integrating Hadoop with mainframe? What is in your mind? Can you just elaborate?
So suppose we have an application in mainframe which is generating, let's say, trading data, right?
Mm-hmm.
So now, so far we are using DB2 in the backend to store this trading data, mm-hmm. right? But now this trading data is we want to store more basically. Now we have facility via Hadoop, so we want to replace that DB2 with Hadoop actually. Okay. Is that doable?
Yes, that is very much doable.
Okay. So is it doable with the adapters which we have to write, or is there any?
No. Everything, pre-existing. You don't have to reinvent the wheel. Everything is pre-existing. This thing I'll talk about when we are talking scoop, that is used for data import and data export. Also, you can directly write your Mapreduce programs also to connect to your DB2 and get in the data with help of Mapreduce also. Or you can write a scoop job which will get the data from your traditional databases to your Hadoop world. And there are connectors also for different things, like there's a connector for MongoDB to connect to Hadoop world. There's a connector for Splunk to connect to Hadoop world. So there are connectors also which are already existing in this over there. You have to just use them and connect to the corresponding platform and get in the data from that platform to HDFS. Does that make sense? Okay, Rohit says okay. Yeah, Kamaljeet, we can get in, we can push in any data into Hadoop HDFS file system. That is, I was saying in one of my previous slides, it is capable enough to handle any data. That is, I was saying in my top in my first 10 or 15 slides, there was one slide which was saying that it can get in any data. So all you have to do is your mapper and reducer function should be able to handle or process your data. So the processing logic need to be written in the mapper or reducer function, or what we call Mapreduce in this word. And you don't have to worry about complexities like scalability of your programs or how that will handle big data, bigger data sizes and things like that. So this is a framework which helps you to process those enormous amount of data which is generated by these systems, import into HDFS, process that data, do merging, do marrying, do slicing and dicing, do massaging of the data, and produce the output either in HDFS or re-export it to DB2. Yes, definitely. This is an industry practice. We are importing data from Oracle databases. We are importing data from MongoDB. We are importing data from MySQL. We are importing data from logs. We are marrying all this data. We are producing analytics by marrying all this data, and creating a data warehouse with all this data, so that all the data is denormalized, which was lying across different databases or different formats across the geographies. We have merged all this data. We have created a data warehouse out of that data, and now that data warehouse is now used for reporting and analytics. So it says is Hadoop ASCII based or plain binary storage? ASCII based or
So Miraj, main thing is, I mean, the way we try to store the data between interrelated systems, like if we try to store data from mainframe to a .NET database or SQL server, actually we face this issue of character conversion.
Okay. Character conversion. Okay, I got a point. I have to cross check that part. Character conversion, because when we import in the data from Oracle, MySQL, or text files or any other files from logs or things like that, I never faced this issue, but I can cross check that part and get back to you. Whether so you are trying your major purpose is to get in the data from mainframe to Hadoop, right?
Yes.
So if the connector is there, that connector will definitely be taking care of that thing, and I'm damn sure the connector will be there for mainframe also. And what is the connector name and things like that, I can definitely cross check that part, because I never got a chance to integrate with mainframe. But if the connector is there, that will be definitely taking care of these character conversions, or if anything happens in between with the data. So I'll just write that question. Hadoop with so I'll get back to you on this question in some time. So Kamalji says Hadoop for reporting, analytics, data warehouse. Yes, it can be used for anything. You can use it for analytics. You can use it for data processing. You can create your own data warehouses over here, and that's the beauty about the system. Kamalji, what
I would extend my question.
Yeah.
Hadoop is basically used for the reporting, analytics, and data warehousing purpose, but the mainframe is still existing for all the transactional purpose, which has been well proven. Is there industry moving anywhere for the transactional system, online system on Hadoop?
So okay. So as I discussed in one of my slides, Hadoop assumes you write once, read many times. So there is nothing like update operation which is possible in HDFS file system. You cannot update the data. Update is not possible in the HDFS file system. It assumes write once, read many times. So coming to the particular thing, transactions, although Hortonworks 2.2 newer version claims they are now we can handle transactions, but practically doing a transaction related thing, Hadoop is not the correct place, because transactions are done on a smaller data sets, and these should be still, as my personal feeling, these should be still done in the traditional databases, be it anything. But when your transactions are done, after that, with the help of either CDC, change data capture, or things like that, you move on your data to Hadoop for reporting or data warehousing or denormalization kind of thing. Make sense?
So that means, Viraj, traditional database system will be required, right? I mean, they will keep that as a temporary copy, or maybe just-in-time copy, and then rest of the bigger data will move to Hadoop, right?
Yes. So now I think 5 years down the line or 10 years down the line, you were designing a system. When you submitted or designed, definitely you would have got a review comment that what will happen to the data which is 1 year old or 2 year old. I cannot keep all this data in my database. My database will slow down after 2 years down the line. So to resolve these things, you will be keep on copying your data to your HDFS world, and your data copy would be lying in your HDFS world, but a recent copy or recent snapshot for traditional systems at least are there in still this is a practice in the industry. Those are there in your traditional databases to maintain transactions, also to do a whole transaction thing. In so as I was talking about things like job tracker, task tracker. So there's a major overhead at the back end on the system to do this all this bookkeeping activity, and to do a small transaction on your large data sets. That is a pretty high, or basically that requires some time. That will not happen in fractions of seconds as that happens in your traditional databases. So if you remember one of the graph where there also I have shown you, the Hadoop comes only in picture. Hadoop is faster only after you reach a certain limit in your data. So for faster queries or for the UI related things, to give a real-time experience to the user, for transitional kind of data, for transitional kind of things, traditional databases are still a practice in the industry. But to give real-time experience to the user for looking into historical data or things like that, in that cases we do indexing in our we create indexes, we slice and dice the data. So say if I as a user want to look I as a business user want to look into the reports, how many orders are processed in last 1 hour. So one way is I can run a query, log into my Oracle database, run a query, select some of transactions where time is between current time and current time minus 1 hour. Another way is as soon as these transactions come into my system. So I'm talking about real-time analytics. Now for that, in this whole session, we'll be talking about batch analytics, but real-time analytics can also be achieved with the help of technologies like Storm and Kafka. Do let me know where you don't understand. I'm just going a little bit more technical. So what you'll be doing in your systems is, as soon as the data which is captured from your traditional database is coming into your HDFS by whatsoever way, by JMS or by MQs or by anything, it is coming into, or by push or pull technology, anything, it's coming to your Hadoop system. There you are continuously looking into reading the data, doing analytics on top of that. So by analytics here, I mean I'm summing up number of orders each minute which are coming to my system and putting into a summarization table. So when I as a business user want to look into the transaction in last 1 hour, that row is available in my database or in my HDFS file system, and I am just reading that particular row and displaying to the user. So that is how I make we try to make real-time uses for the enormous amount of data which is pushed into the system. But for transaction, still the industry practice is for traditional databases, because our HDFS file system is not made for updates, and you will not be able to do updates when you will be looking. I'm just coming to, and you will not be able to do updates when you will be looking into this whole file system with the help of Hive. where you'll be interacting with this file system from query-like language, SQL-like language. Yes, go ahead, Rohit. I think that was Rohit. Yeah.
So yeah, sorry if I'm asking too many questions. Just one last question, voice. So I'm just putting one example. So let's say when we are using Facebook actually, and you said that Hadoop is write once and read multiple times, and there is no scope for update, right? So when we are using Facebook, let's say when we write comments or all those things, they might be going into traditional database because we go and update those comments and we want to delete those comments, right?
Okay.
But then if we upload video, we know that video will not be updated at all, right? So video file can it be pushed to Hadoop right away? Is that a good example?
Yeah. Okay. I'll just rephrase your example to make it perfectly visible what is happening at the backend. So Facebook is using databases, NoSQL databases or graph database. So I think they are using Giraffe. So what is the beauty about these databases is, so I'll give you an example. Okay. I'll just deviate from the topic, but I'll just deviate from this topic. So let me open an example of, just give me a sec. Let me open an example UI. I don't have that thing in any of my PPT, but let me open it to explain it.
And just want to ask, I mean, these questions are relevant for others also. I'm not taking unnecessary bandwidth here. Abhijat, Prakash, Girish, what do you think?
I'm not sure what this picture is, but I'll try to
discussion will help.
Sure. So let me tell you one example how this goes to NoSQL databases, how they take care of this thing. So I'll just take an example of Cassandra. This is one of the NoSQL database. Let me open any write protocol which is defined somewhere. Okay, here it is. So what happens in this traditional database? I'm just giving you an example of Cassandra. Same thing happens somehow in other NoSQL databases. So when you're putting your data, so there are the two things coming in picture now: HDFS and NoSQL databases. NoSQL databases are column-based databases where you can create tables based on columns. I'll not go deep into this, but let me explain you what happens in your example, what you're saying. So that user comments would be going to Giraffe database. So here I'm giving an example of Cassandra, and video files might directly go to HDFS file system, but the processing backend logics are pretty much similar over here. So what happens is when the user writes a comment in Cassandra, what happens is that goes to your commit log. So the beauty over here is if I have to insert something in Oracle, there's a seek time which will be involved where that record need to be written, which this record is candidate of which table, which row, if indexes are there, the indexes would be taken care of, all those things. But here the beauty is that record will be written simultaneously without even a single spin in disk, and that will return to commit log. And a copy of that would be written to your mem tables. Don't worry about the complexities of what is mem table is, what is SS table is. If you require, I can go deep after this session with you. So a record would be written to mem table also. And so say I have updated a row called employee. I just updated a comment from Rohit with the user with the ID for that comment is Rohit123, and the comment said I'm confused with how the write happens. And later on, the Rohit just updates that comment, and now it's clear to me how the writes happen. So the first copy of that record will come to the commit log and will be sent to the mem table. And the next record will again go when you update that will again go to the commit log and the mem table. And beautifully, when you request for that record, the latest version of that record will be sent to you. And at the back end, compaction like thing happen, which flush on the older versions of your record, and only the current versions are maintained in the system. So this is how that is beautifully taken in your NoSQL databases. And in HDFS, you are moving the data which need to be done on which you want to do batch analytics. Does that make sense? If not fully, but somehow. So basically, these NoSQL databases maintain different versions of your data. If you have changed something, different versions are maintained, and later on, the older versions are removed from the system with the backend technologies in the system. So in Cassandra, there will be something like compaction, which will keep on running, and the latest version will be pushed will be pushed onto your SS tables, which is the real hardest. So all the seek and everything happens at the backend, and to the user write is very, very fast. Okay, let me go back to the PPT. Okay, so any other questions before I go ahead? So guys, this is the first step to the big data world. This whole session would be the first step to your big data world. There are a lot of other technologies also, like I'm talking about NoSQL databases, then real-time processing. Here we'll be talking all about batch processing. So then real-time processing. Then there are new things like Spark coming up and things like that. But this whole session will give you a step first, or first steps, how to look into the data, how the data is stored in these big data technologies, how the data is processed with the help of these technologies. Then, if required, we can after the session, there are other sessions also related to dedicated to Cassandra or MongoDB or NoSQL databases. Then the analytics, particularly related to analytics. So, but keep on asking me questions. Whatsoever I do in my personal life, whatsoever I do in my office for analytics and things like this, I'll try to explain as much as possible what I know. Keep on asking me. That also makes me feel good that you are able to get what I have. And if the question is pretty much unrelated to the topic, I can discuss that thing after the class also with you. So this is how we read the data, and now let's see how to submit this job to read the data. So to submit the job, all I have to do is, so first thing what I have to do is okay, I was going to the thing. Okay, before that submitting it, let me tell you how this thing is done. So other than this, what I've shared you in the softwares folder is something called Eclipse. Does everyone knows what is Eclipse? Anyone does not know and not seen the Eclipse UI? This is just a tool which helps you in writing and compiling the Java code. And any yes, no? No, yes, no. Okay, okay. You can listen me at least, right? Okay, I will just after one. Okay, Akash says just Eclipse. So Eclipse is nothing, but we'll be using it to write our Java code, which we'll be using for Mapreduce part. So just try to use it. But after Mapreduce, we'll be using the hyphen tick, where Mapreduce code will be automatically created to you. But if you understand the Mapreduce part, that will be easier for you. So just download the corresponding version of Eclipse, 64-bit or 32-bit, based on your laptop. And once you download that, it would be something like this. Once you download and unzip it, it would look something like this. And once you double click this eclipse.exe, something like this UI would open for you. Okay, I'll just share the screen. So So while the time Eclipse is loading, there's one more thing which I'll be sharing with you. That is the code, the whole code base which I'll be discussing in Mapreduce or in Hive and Pig and things like that. I'll share with you. So in the same shared drive on the same ID, I'll be sharing you one more folder called code. So here there are project called Mapreduce Maven project and Hadoop project. You can import those projects to Eclipse. I'll just show you how to import them. If you want to look into the real Java code and if you want to change anything, you can just import them. Otherwise, there's a jar which I've kept over here, which has all these classes which I'm discussing in the class pre-configured in it. So you have to just run the command which I'll be running in next few minutes. So Eclipse is probably starting up. It takes some time. So guys, if you have 4 GB of RAM, do not try to run both the VM and Eclipse together. They both are memory intensive processes. So okay, so before that, how to get all this code into Eclipse. So once you have downloaded this code which I was just showing you over here, just download this whole project or this one, any one of the project. If you are not from Java background, I request you to download this project. If you are from the Java background and you understand the complexities of Maven, you can download this project. Just download any of these projects, and after downloading this project, all you have to do is click on File. I'm just reading the steps. If you want to write down, you can just write them down. Just click on File, click on Import, click on Existing Project into Workspace, import existing project into Workspace, click on Next, browse that project, wherever that project you have downloaded, that go to that particular directory. Once you browse that and press Enter, a project name would appear over here automatically for you. Select it as a right click on Finish, and once you click on Finish, the project, something like this will appear to you on the screen. So Rohit, this code is in the shared drive. I have not shared it till now with you. I'll share this code after this session. You can download these codes also, and I'm just telling you how to import this code into Eclipse. So once you download the Eclipse and double click this eclipse.exe file, something like this browser will open for you. And once this browser opens for you, how to import this project, all you have to do is wherever you download this project, either one of them, click on File, click on Import, click on Existing Project into Workspace, click on Next, click on browse that directory wherever you have placed the project, and the project, once you browse the directory, the project name will automatically appear here for you, and that will be checked it, and click on Finish. So once you click on Finish, it will take a few minutes, and all the project will be visible to you. And before that, if you're opening Eclipse, just ensure that you have Java installed on your PC. If you don't have Java installed on your PC, go to Sun website, or just Google download Java or install Java, and the first website will be from Sun, and you can just install the Java from there. Okay, so any questions till now before I just show you how to
Miraj, before you
yeah
Miraj, just one question. I think before you showed that block size is 64 MB actually. So in day-to-day life, when we create the data, normal simple single rows are not in that range, right? So should we be conscious about writing anything into Hadoop which is less than 64 MB? Because then we are again creating so many of metadata and all those things, same thing, right? Performance will go down.
No. Okay. I'll come to this thing. I think that is a pretty good question. I'll come to that part. Just write down this question, Rohit. I'll discuss in detail with you when I'm discussing what is a split. So in the previous slides, I have skipped what is a split. That is a logical division of the data. So there is something called split on top of blocks. So when you are reading the data, you are reading the split. So a whole split is passed to your mapper rather than the block. And normally the split size is equivalent to your block. So this logical distribution of the data where your line is spent over block, and you want to process single line to the mapper, that is taken care with the help of a split. And I'll show in more detail when I'm discussing the Mapreduce part, but the split comes in picture for all this thing. So there's an interface on top of block, and you interact with a split, and a mapper is created for a single split. 1 split is equals to 1 mapper. So Rohit says okay. So let me tell you how to create a jar out of this program, and how to get that jar to your Unix world and how to run that. So just ping me quickly, yes or no. Do you understand? Although I've written who are from the Java background, but just ping me quickly on the chat window for my recall. If you are from the Java background, are you familiar with these kind of codes, and are you familiar with the Maven? Just quickly, yes or no. So I'll just again get on statistics. I'll explain in that detail only. So that's just the reason I'm just asking it again. Abhijat says no. Akash says no. Kamaljeet yes, yes, but out of touch. Okay. Okay, and there are a few others. Garish and Grish I think was not, and Akash was no. Okay, and Vijay and Rohit. Grish, I'm still processing everything. Okay. Okay. So I'll not go much into the Java complexity. There's none of you are from the Java background, and none of you would be really writing then the Mapreduce codes or using these kind of file system utilities. But I'll explain you so that that's there in somewhere in your head. And when so required, you can just push that memory into your SSD, and that could be helpful for you while understanding the other things. So I'll not go in the deeper details, but I'll try to explain as simply as possible. Okay, so to create a jar, what we have to do is we have to just click on this file, click on export, and click on runnable jar, click on next. Select the class file which you want to export, and so here in this example, I'm trying to run a word count program, or not the word count program. Let's read that merge local files to HDFS. So this is a program which I was showing you in the slide. So this is merge local path into HDFS. So what I do is file, export, runnable jar, export. Select that file. That would be somewhere. So in case if you do not see that in this drop down, all you have to do is just go back to this program, cancel it, and right click it and click on run as, and run as Java application. That will throw an error, but that will register this program as a main program into your this list. So that will throw an error, Java error. I am not worried about that, but while exporting that will be visible to me. So I'll just again go to file, export, runnable jar, next, and now this will be visible to you. Merge. Can someone see? Merge, yeah, merge. So this is visible to me, and then I'll just browse a location where I want to place the jar. So I say this location. So I just select this location and I just give a jar name, and I select this radio option package required libraries into the jar, so that all the dependent libraries which are required to run this jar into Hadoop Word are packaged inside this directory. Otherwise, I don't have to give any references to any of the directory, and click on finish. Once you click on finish, the jar will be copied into that location which you have just now selected, and the jar will be visible to you. Once the jar is visible to you, I have shared one more software in the software folder that is called WinSCP. So that is a file utility, FTP utility. So when you double click this exe, something like this opens up. You can click on new, click on the host name, that is again 127.0.0.1. And port would be I think 22. Just a sec. Port will be 2222, 4 times 2. Username Hugh, again password is Hortonworks, and click on login. And if you can save it also for the future purpose. So if you save it, next time you can just double click on this and it will open it automatically for you. So on left hand side on this console, there's my Windows machine, that is my local machine. On right hand side, this is your Unix VirtualBox. So the jar which I have created by the name of Mapreduce 1.1.snapshot.jar, all I have to do is drag this jar to your Linux world, just drag it and leave it. It will be copied to your Linux world. So this is how I do a file transfer in the Unix world. So once this jar is copied to your Linux world, you can open your again the putty and go to the folder wherever you copied it. Just press ls. So before that, I'll just clear the screen. Press ls and the jar will be visible to you. So this is the jar. So now we can run this jar. So to running any of these Java files, don't worry about the complexity at the backend. At the end of the file, I've given the help also how to run this Java file or this jar, submit this jar. So you can copy this whole command directly and paste it over here. Beware, okay. So beware that these directories exist into your system. Otherwise, you have to create these files which are input and output to this to these files. So here I've given the input that a local file system as Hue user design pathshala data file. So let's look what inside this directory is. So there are probably 3 text files. I'll just get any one of them. Oops. So this has some data, and similarly other files also has just some data. And when I gave a command Hadoop jar Mapreduce my class file name and input directory and output directory, so this would be a file which would be created into your Hadoop world. So let's look into that. Hadoop fs minus cat. I am printing this file which is created recently for me. Input file.txt, and I'm just trying to print that file, which is a merge of those. So see, this is a merge of that file, these 3 files. So at the backend, the job was created for me, or the signal was sent to the job tracker, and the task tracker came in picture, and everything happened at the backend. And if you look into this Hue UI and the job browser, okay, so that job is finished. If the job is running, that will be visible to you over here also. So when we are running some other job, I'll show you over here. Does that make any sense to you till now? Before I move on to the Mapreduce world, I'll not go deeper into other examples as you will not be using the Java to interact with Hadoop-based file system. But I just wanted to give you a glimpse of how this happens at the backend, so that you have somewhere in your heads later on, if required, at least to tell to your team.
Yeah, I think Miraj, you went a little fast actually. What was this job exactly doing? It was just merging 2 files?
Yeah, yes. So as I explained in the PPT, this job was just merging all the files inside the directory. So the first input path for that job was first input parameter to that job was the local directory, that is the data files which are lying in the local directory, which I have just shown you. So if I say ls and what is lying in this directory, so there are 3 files, 1, 2, and 3. So all these files are merged and placed into the HDFS by this file name. So I've shown you this file. When I've created this file, this is Hadoop FS. Now I'm given Hadoop FS. Here I am not given Hadoop FS. So this is the local directory which I was looking at. This is now looking into the Hadoop file which is created for me. So if I just say tail minus tail and this file, so a part of that file would be printed, which would be looking similar to this. Oh, sorry. So see, only the part of that file is printed. That is equivalent to one of this files. So all these files are similar. I think 1, 2, and 3 is just copy of each other to create some extra data. And this is a file which is created for you. So this is one of the way how we interact with the Hadoop-based file system, other than your command line utility and Hue UI. There could be other ways also, but I just wanted to tell you this is the way how we interact with from Java. But I'll request you to understand the Mapreduce Java code. That will be useful for you. I'll not much focus on this reading the file Java code, because none of you belong to Java code and will be doing the coding on this thing. So I'll not waste much of the time on this slide. Any other questions or anything you want to discuss on that part before I move on to the most awaited Mapreduce thing? So I'll just recap what we discussed so that it does not confuse you. We discussed some of the softwares. We discussed how to build those jars and things like that. So I'll just recap quickly. If you have any confusion, do let me know. So what I discussed is we downloaded Oracle VM.exe. We double clicked it. We installed it inside that Oracle VM. So I'll just share my screen also. Okay, my screen is shared. So that Oracle box looks something like this, and there I downloaded the OVA file and I started an OVA file, and then I talked about something called as WinSCP that is used for transferring data from your local file system to a Unix file system. Then I also talked about PuTTY, which is doing an SSH to your Unix file system, which is your sandbox. And then I talked about Eclipse. So Eclipse is writing your Java code and creating jar for you, an easier way to create jars and writing the Java code for you. You can even open that in a text file and write it. And then we created a jar of this program which we were discussing it, and with the help of with the help of Eclipse file export, we created a jar. And before that, we imported the whole project with the help of import. And when the jar is created, we have copied the jar to your Unix word, and from there we triggered a Hadoop jar command that really submits a job to your job tracker, and job tracker has done that job. And once the job is done, the finished signal is sent to the client. Any other questions? Any questions before I go ahead into the Mapreduce thing? Okay. So let me explain you how the Mapreduce.
So Miraj.
Yeah, go ahead.
Miraj, in the job which you ran, actually, you are trying to merge three files actually, and let's say job tracker ran, and then it sent you finished signal. So when finished signal was received to this Unix interpreter, then it printed the file on console, right?
No. I personally printed the file by giving Hadoop FS -cat command. It just sent me a finished signal, and that is printed as on my screen that job is finished.
Okay.
So let's see how the Mapreduce really works. So anything before that, I have two questions. Do let me know if you don't know anything about these two things, otherwise understanding Mapreduce will not make any sense to you, and you will not be able to understand this whole concept also. Everyone does anyone not understand what is key value pair and what is hashing? Ping me on the chat window, or do let me know if you don't know what is the key value pair or what is hashing. Otherwise, you will not be able to understand what is Mapreduce. Abhijat says sorry. Okay. Desh also says no. Okay. I'll explain it. So key value pair is nothing but there's the key uniquely represents our value. So key could be anything. So for example, I have an employee object. So key for that object could be employee ID. So that employee ID is a unique distinction for that object. So key value pair are nothing. Key is a unique distinction for your value. So key value pair are created out of your data to do the processing in this whole Mapreduce phase. So somehow you create some unique key for your data for each record in your data, and with the help of these key value pairs, you process your data somewhat in your mapper phase and somewhat in your reducer phase, and finally print output. So all of your data is divided or read in a key value pair everywhere in your whole Mapreduce lifecycle. And the beauty about this key and value pair is this can sustain or this can hold any kind of data. Rather it's a text file, rather it's a blog, rather it's a video file, whatsoever the kind of file. All you have to do is you have to just define the particular key for that file, and that would be for particular record, and that would be passed on to your mapper phase, and that processing would be done. How that is done, I'll just come to that part. But the beauty about key and value pair is any kind of data can fit in this architecture. Only the thing is you have to change your thinking to understand this part. You have to little bit change your thinking now. Abhijat, not exactly primary key of the Oracle world. A key could be anything. Key you can create or you define your own key. What would be the key for your data based on the logic you want to run, based on the processing you want to do in your Mapreduce world. The example which I told you was a primary key example, but that would not be always the case. Key could be anything. Only the thing is key would be uniquely defining your records, and record could be anything the way you want to process the data. So for example, I want to process the data of employees table only, but I want to look into number of employees in each department rather than doing something on the employee ID or employee. So in that case, I would create a key as department ID rather than employee ID and will pass that data to a mapper or reducer phase. So in that case, I'll be summing up the number of objects available inside the department key. So all the values which have same department, all the employees which have same department will come inside the key of department ID, and all those values would be available to the system. So at the backend, I'll just sum up the number of employees represented by the department key and will produce the output, the department ID and number of employees in that department. So key could be anything. It is not like primary key of your data or of your record or of your row. It could be anything based on the processing which you are planning to do in your system. Make sense? Okay, Abhijat says yes. Okay. So second thing, what I'm saying is hash value. So hash value is, or hashing is, one sec. Let me just open some picture if it is visible, otherwise I'll draw it on Excel. So yeah, there is one picture on Wikipedia. I'll just open that part only. So hashing is nothing but it could be any function which could be used to map your data to a digital data. So this hash function would be intelligent enough to figure out some digital value out of your data, whatever your data would be. So if my say key is employee name, so this hash function would do some magic on that data, would produce some unique numeric value for that employee name, and that value would be distinct for each name. So here in this example, you see the hash function, when I pass the key as name to this hash function, it produces different values for different names. The hash value for two different names could also be the same. In that case, the hash value of those things would say. How that will affect in our system, I'll talk about that thing in little in some time. But hash is a function, or hashing is an algorithm which tries to give some unique value or digital value to your arbitrary data sizes. Okay, so what happens in mapper and reducer phase? Data. So these blue blocks are records in your split. So all the records in your split are passed to your mapping function. Map function produces key and value pair out of your records. That records are then sorted and shuffled in between. I'll talk about that short and shuffle phase in a meanwhile. And that goes to a reducer. The key and value pair which are produced out of your mapper class go to a reducer as key and value pairs. Reducer again do a reduction part or reducing on those key and value pairs and will produce the output. So in the previous example which I was talking about the departments, so this mapper key will produce a key as for each employee which belongs to a department analytics. So it will produce a key as analytics and value as that employee object. So for each of the employee, the key would be department on which it depends to, and the value would be that employee object. And the reducer phase, all the similar keys would go to a particular reducer by the magic of that in between hashing thing. So the hash key hash key for that department would be calculated same every time the hash function is called on that key, and that will ensure that those keys reach to the corresponding reducer, and then the reducer will sum up number of employees available for that particular key and will produce the output as the number of employees available in or existing in a department. I'll just explain that thing in more detail, but anything which is coming to a mapper phase is produced as map and value output, and that's key and value output, and that key and value pair then passed on to reducer phase, and reducer reads or do a reduction on those key and value pairs and produce the output. We'll see it in little bit more detail. Let's see, this is my data. These are different blocks lying in an HDFS. And I have to do a count of colors in my data. So there's each different color blocks talks about the data or a record in my block. And I'll be reading one by one record from this data and want to count the number of different colors in my data. So what I do is there will be a mapper which will be created for each block. So say the block size is equal to split size. I'll talk about a split when we move to the right topic. This mapper, what this mapper do when this mapper will read the record, it will produce key and value pair something like this. Key as the color and value as the count of that color. So this mapper will keep on reading one by one block. It will read blue color, one record blue. That will be passed to this mapper. This will produce an output like key as blue color and value as one color, and so on. So it will keep on reading these records. And once this produces an output as key and value color, that key and value color will go to your reducer. So all the blue color keys will go to a blue color reducer, all the red color keys will go to a red color reducer, and all the green color keys go to a green color reducer. And that is taken care with the in-between hashing algorithm because each color will have a distinct hash code. If any color has the same hash code, that blue color, red color keys would have also gone over here. I'll just talk about that in meanwhile. For time being, just assume that all the distinct keys goes to a distinct reducer. And once the reducer receives those keys, so see from all the mappers, the right color keys are going to right color reducer, and reducer gets something like this key and the list of values. And on the reducer side, what I'll be doing is I'll be just summing up these values and producing the output as the color count. So on the reducer side, I'm just summing up these values which I've received as blue color and the count as 100. Does it make sense till now before I go into the further complexities about this whole algorithm? Akash says yes, kind of. Rohit says yes. No, that was long back. Rohit says yes. Akash says yes, kind of. Others, shall I assume the same? Okay, Kamalji also says yes. Okay, so this is a basic MapReduce workshop. I'll talk about the further on complexities of this system, and the output would be 3 files. So this is how it will happen. The one by one block will be read from each block, and it will go from the mapper phase. Mapper will produce something like color, and the count is also there, but that is not done over here. So color and the count mapper will keep on producing, and those color and count key value pairs will go to your reducer, and reducer at the back end will do a sum of all these counts, and it will produce an output. Okay, Avijay says somewhat, but perhaps still about. Okay, I'll explain it in more detail. Don't worry about that part. Okay, but try to get as much as you can, and then I'll try to explain it again. Let's look into this example. It will make more sense, and then I'll try to explain it again. Abhijat says pre-hash. Okay, Abhijat, just don't worry about this pre-hash thing. So this is what I was talking about, short and shuffle phase. This short and shuffle phase is transparent to us. We don't worry about this phase. This is automatically implemented at the backend. All we do is write our mapper code and reducer code. I'll talk in detail about short and shuffle phase, but I don't want to introduce all the complexities at the first step. So I'll talk about the short and shuffle phase, this pre-hash thing. But what I wanted to explain with the hashing part is that hashing part ensures that your reducer receives the data which is intended for that reducer, and that is taken care with the hash value of the key which is produced from the map. So in this case, the map key was color, and the hash value of that color made it easier for this in-between magical phase, short and shuffle phase, to send the correct keys to the correct reducer, correct key and value pair to the correct reducer. So all the blue color keys has reached the blue color reducer. If one of the blue color key value would have reached this reducer, then in that case it would not have been possible for me to produce the correct sum of blue color, because here it would have produced 99 and here it would have produced blue and 1. So I would not have produced the correct count. So that is what I was trying to explain. This hashing function in between is magical function for us. I'll talk about this thing in detail. But for timing, just assume this is a magical function for us, which takes care of distributing your keys to the intended reducers which are intended for those keys. And this everything happens in the backend with the help of hash value of your key, which you produce out of your map function. Make sense? Okay, Abhijat says thanks. Okay, this pre-hashing thing will come in detail when we're talking about the complex Mapreduce algorithms. So I'll not introduce the complexity of pre-hashing at this phase. So let's talk about this example, then I'll come back to these slides. So say this is my data, how it's looking like. These are two blocks of my data. I want to read it. At the end, I want to produce the count of different words or count of different fruit names available in the file. So what I do is I read one record from my block. So one record here is one line. That is a logical distribution of the data. By default, if you don't define a separator in your record, the default separator is new line only. That is /n. So one record is read from your block that is passed to the mapper. But in the mapper phase, I'm doing is I'm producing key and value pair. So here key is the fruit name and value is the count of that fruit. So that is 1, because one word I'm reading at a time in the mapper phase. And it produces apple 1, orange 1, mango 1. And similarly, the same mapper is called for next line in my data or next record in my block. And that goes again to mapper, and mapper produces orange 1, grapes 1, plum 1. And in between short and shuffle phase, those keys are sorted and shuffled and sent to the intended reducer. So reducer receives something like apple, 1, 1, 1, something like this. For these 4 apple words, and at the reducer end, what I'll do is I'll just sum up these keys and produce the output. So as an output, I'll get apple 4, grapes 1, mango 2, orange 2, plums 3, kind of thing. Now, does it make more sense? Still confusing? I'll go into other complexities, yes, but at least this concept makes some sense. How the key value pair is taken care and helps in producing or analyzing different kind of data. You think of any problem you can fit in this key value pair example. Rohit says yes, good one. Abhijat says great example. Okay, cool. Okay, get it. Okay, so anything which is input to the mapper is a key and value. Mapper produces key and value. Now I'm adding one more complexity of key and value, which is input to the mapper. In the previous example, that was just the data which I've represented. So for the sake of simplicity of understanding, so there I'm adding one more complexity over here. So anything which is inputted to your mapper is key and value pair. Mapper outputs key and value pair. Reducer takes key and value pair as an input. So reducer takes key and pair of values. So in the previous example, if you remember, I've showed reducer take apple as a key and values as 1, 1, 1. So sorry for this pathetic writing. So it takes key and the list of values. So reducer takes key and list of values and produces key and value pair again. So every interaction happens in key and value pair, irrespective of the fact data is coming from where and going where. So when we read the data from a file system with the help of input readers, the data is read in key and value pair. Data is submitted to map class in key and value pair. Map class produces some intended key and value pair, what is intended to do a processing on, and that goes to a reducer phase, and reducer again read those key and pair of values and produces key and value pair as an output. Now here the one more complexity about key and value pair comes up. So by default there are file readers which will create default key and value pair out of your data. So if you don't define any file reader, the default file reader will be initiated for you for reading these records from the block. And in that case, the key would be so when this data would be passed on to map phase, it would be something like this. Let's go to an Excel and let me explain it in little bit more detail. Okay, we still have 15-20 minutes. Okay, so I hope you can see my Excel sheet. Apple, orange, grapes, GRA, grapes, range, not make it comma, let's make it a space. So these are words in a line. Orange, fine.
We don't see your Excel.
Okay. Now?
Yes.
Okay. So say this is my data which I was reading over there. So orange, apple, this is one line in my record, this is second line in my record, orange, plums, grapes, this is third line in my different block, say orange, grapes, plums, grapes, orange, banana. So say this is block 1. I'll not use the red color, we'll use it for different purpose. And this is your second block. Okay, so for each block there will be one split which will be initiated. That is clear to you till now. So the split is a logical division of the data. We'll talk about this thing in more detail in some time. So one split is created for this, one split is created for this, S1, S2. So these are two blocks. The yellow color is block 1. Block 1. This is block 2. Block 2, and this is the data inside that block, and there's a split on top of those blocks. The split is again a configured thing in a Mapreduce Word. So one mapper would be created for a split. So there will be one mapper for this split, mapper 1, and there will be one mapper for this split, mapper 2. And these records will be read one by one and passed on to your mapper function. So mapper has a function called map, which will be called for each of the record. So this time this will be called twice. This again for this mapper again this will be called twice. Oops. And this will be called twice. So this mapper function would be called for you twice. And the input to this mapper function would be key and value pair, which would be produced by your input or your file reader. So that so the input, sorry, mapper input. So the default, if I don't define the default, if I don't define any file reader, the default file reader will come in picture. And what will the key and value pair produce out of that default file reader? I'm just printing that thing over here. We can definitely change all these things. I will talk about those things in detail, but for time being, just assume we are using the default file reader. So default file reader will just create a key as an offset value, byte offset value of your record. So the byte offset value of the first record is 0, and the value is nothing but your whole record. So this, say assume there are 20 words or 20 characters in this file. So byte offset value of this record is 20, and this is the value which will produce. And say again there are 20 more characters, so the byte offset value of this block would be 40, and the value would be this. And say again there are 40 or 20 or more in that, so the byte offset value for this would be 60, and this would be this. So these key and value pairs would be produced out of the file reader, which is reading this data for you, and passed on as an input to your mapper phase. Okay. Okay. Now then, and the mapper phase, as I want to just count the number of fruits, what I'll do is I'll try to somehow parse my data, each record which I'm getting, and produce the data in such a fashion so that I can count the number of fruits in my data. So what I'll do is now I'll try to split this value. I'll ignore the key because key does not make any sense to me. I am not worried about this key. So I'll ignore the key in my mapper phase for this particular example. The key would be important to you, but based on what you are doing. So I just copy paste it over here. Okay. So I'll just ignore the key. In the mapper phase, what I'll do is in the mapper phase, what I'll do is I'll parse this value and split this value based on space, and for each word I'll produce a key and value pair. So what I'll produce is something like this: key as apple, and value as 1, because 1 is the count for this apple, and there will be few more rows which will be added. So I'll just cut. Just a minute. Actually, this is a little complicated. So I'll just cut this part. I'm just talking about this mapper now. For this record now, I'll just put it a little bit down. So this mapper will produce this key, something like this: apple 1, orange 1, and grapes 1, and so on. It will keep on producing key and value pair like this. Okay, and those key and value pairs would be sent as in between shuffle phase will come in picture. So let's look at what this mapper, what whole this mapper will produce. Would be something like this: apple 1, all the mappers I'm talking about: apple 1, orange 1, grapes 1, and for the next line similarly, for the next line it will keep on producing and so on. And in between short and shuffle phase, what it will do is it will segregate the keys based on the hash value, and will group them. Similar keys will be grouped together, so it will produce something like apple as a key. Sorry, apple as your key, and value as 1, 1, 1, 1, and this will be an input to your reducer. And this reducer will then what it will do is it will loop all the values for the particular key and will produce something like apple, 4, 4, and this will be printed to your HDFS world. So there's one more complexity which I added over here is your data is also read in key and value pair, that is passed on to a mapper phase in a key and value pair only, and mapper phase produces key and value, and reducer inputs those keys and value and produces another pair of keys and values.
So Viraj, you said key and hash value does not have one-to-one relationship, right?
Key and
so
hash.
If it is not one-to-one, then
okay.
Sometimes, right?
Okay.
So if it is not the case, then maybe Apple also has a hash value of, let's say, 13, and Grapes also has hash value of 13, right?
Yes.
And then when it tries to go to reducer, it may want to merge those two, right? Because it is acting on hash value, not the key.
Okay, sure. Rohit, just give me a sec. I'll explain it. Just give me a sec.
Okay.
Looking for some beautiful Excel which I would have created previously. So, but don't worry, I just keep on deleting them. So what will happen is in the reducer also there's something called reduce function. So let's say there are 3 reducers which are taking care of this whole problem. I'll just copy this in the bottom for the visibility. So the output which will be produced, or the input for the, so there are 3 reducers which is taking care of all this problem. So reducer 1, reducer 2, and reducer 3. And say the hash value of Apple is 10, hash value of Orange is 12, hash value of Plums is say 22, hash value of Grapes is say 52, and banana is say 37. Okay, so what happens is these reducers take care particular ranges of hash value, and that's how the key and value distribution happens in the system out of mapper. So particular range is taken care by a particular reducer. So when I'm saying a particular range will be taken care of a particular reducer, so let's move it somewhere here. Just give me a sec. Let me just little bit beautify it for your understanding purpose. So hash values, and this reducers Now say my reducer 1 is taking care of these 3 hash values, this 3. My reducer 2 is taken, so basically reducer 1 is taking care of anything less than 50. Reducer 2 is taking care of, okay, say it's taking care of anything less than 40. Reducer 2 is taking care of anything greater than 50. And reducer 3 is taking care of anything between 30 to 50, and I'll just make it less than 30. Okay, and there's no 30. Okay, sure. So this is how reducers are taking care of the buckets which are created for reducers to take care of keys. Okay, so this will definitely be your yellow color reducer, and this will be your, say, blue color. So this will be your blue color reducer, and this is your or brown color. So this is a brown color reducer. Till now, make sense, right? So this reducer will definitely get all the apples wherever they are processed, and will be sent to this reducer. Then the plums will again be sent to this reducer, and reduce function will be called for each key and value pair. So when I'm calling the reduce function, I'll get a key as apple and values as a list of values. So in the first call of reduce function, this data will be passed it. Reduce function will do all the processing on all the values and produce an output called apple, 4. Next time reduce function called for this particular R1 reducer, it will be called with a key called plums and value with 1, 1, 1. So in that case, it will again produce an output plums, 3 as sum of these values, and so on for other reducers also. So this is how the beauty of key and value pair works up, and in between hashing tries to distribute your data equally across the reducer. So this hashing function is used to basically distribute your data across the reducers, and number of reducers spooled in a system is configured thing. You can parallelly spool as many reducers as you want based on your data requirement and things like that. And this is how you are able to achieve parallel processing in the system. So we are segregating the tasks which need to be done to different task trackers to a particular instance of reducer. Make sense, right? Okay, Rohit says yes. Any other doubts, anyone? But the hash values are okay. What if repeated? Okay. 1 minute. So Rohit is saying, but the hash values are unique. What if repeated? So say this is also comes up with the hash value 10. In that case, also this key is different. This is an orange key. This is an apple key. So this hashing will just bucket this data to this particular reducer, but then the key and value pairs are passed. This is a different key. So for the plum key, the reduce function will be called separately, and for the apple key, reduce function will be called separately. Although this data is lying in a single hash bucket, but these keys are different because of the equalities on these keys. If this is a string, I'm just doing a string comparison. If this could be something else, I would be comparing those objects for the for the compatibility or for the comparison of the keys. Does that make sense? So if this would have been employee object is the key, or department object is the key. So department object with the similar department ID would be the key. So all the values related to the department ID would have gone as comma separated into these values. So there are two things over here. One is the hash value and one is the equality function between your objects, between your keys. So if the equality function between our keys says those both are equal, so if I implement or if I overload my classes and implement something like that, when you compare apple dot equals plums plums, it should return true. So in that case, I'm telling my function, hard coding the function that apple is equivalent to plums. And in that case, these two keys will be assumed same, and I'll be producing values something like this. Make sense, right? So till the time you are comparing keys as different, although they could be candidate of same bucket, they could be processed by the same reducer, but if they do not satisfy the equality function, they cannot be compared same, and they will the reducer function will be called twice for them. So for all this option, as I was calling map function on top, here the reduce function is called for all of these operations. Yes, please. There could be many entries called plums. So all these plums would come over here. So I'm just delete this. This does not exist in the word. So all the entries for the plums will definitely go to the reducer which has plums, and that will be the values would be 1, 1, 1. So based on the number of plums in this input data. Was that your question, or you were trying to ask something else? Which were you are trying to ask something? So I assume he was asking the same thing. Till he does not reply on the chat window or comes on here.
I think he's saying that if apple is equal to plums, then plums entry will not be there, right? Because then we are counting plums count against apples.
Yes. So that object would be the same only. Yes. So either one of them entry would be there. Here we can. So Greece says yes, got it. Okay.
Go on. I'm sorry. Did I stop?
No, fair enough. So sure, Chris, let's go ahead. So we were discussing about mapper and reducer phase. So everything what mapper consumes is a key and value pair. What it produces in key and value pair. Reducer consumes key and list of values and produces key and value pair. And in between there is a short and shuffle phase which do all this hashing and things like for you, and ensures that the similar keys are reaching similar reducers, and same key is not reaching any two reducers. And also the keys are sorted in between. There are different reasons for that. We'll keep on discussing those things when we'll talk about advanced MapReduce. So all we have to write is just the mapper code and the reducer code, and rest all thing is done magically for us. But everything is configurable. We can change anything. We can change in between any logics, anything like that. Everything is open source. Also, everything is configurable. Also, so we can change anything. But as a user, in 90% of the cases, I just have to write the mapper code and reducer code, and rest everything is taken care by the Hadoop code for me. So
that would be in Java, isn't it?
MapReduce, yes, MapReduce in Java. But when we're looking into other technologies, you don't have to worry about Java. So there could be the cases where you don't require input reducer, like you are just filtering the records. So you are parallelly filtering the records and producing the output directly from the mapper phase. In that case, reducer might not be required. So there could be the cases where you don't require reducers also. Yes. So this is a common MapReduce program. We are running out of time, so I'll just quickly walk you through, and then we can discuss this program in a little bit more detail in our next class. I'll just try to run this program in next 5 minutes and try to wind up, and we will discuss about this program in detail in our next class. So here I've created, so this is a mapper class which I was talking till now. So this mapper class is tokenizing my input. So this key would be here your byte offset, and value would be apple space orange space plums. So I'm tokenizing. I'm basically dividing this value which I've read into by spaces, and for each word I'm producing word as a key and value as one. So key and value pairs are emitted from this mapper for each record which has been passed to this map function. This is a simple MapReduce code for that problem, and the reducer phase it will automatically get the key as apple and values as 1, 1, 1. So in the reducer phase, I am just looping all the values, summing all the values, and producing key as apple and result as the total sum. And this 2 lines program over here and 2 line program over here does all the word count for you. And the next thing is I have to configure this thing which I was keep on telling in the job tracker and task tracker thing. So you have to just set the configuration things. So in this configuration, just ignore these lines. ignore this line. Just ignore. So what I have to do is I have to just tell my configuration what is my mapper class, what is my reducer class, and submit the job for the program. And two things which I have to give for any Mapreduce program is the input path from where to read the data and where to produce the output data. So just give four things: mapper class, your reducer class which you have created over here, and from where to read the data and from where to output the data. This is a configuration thing, and this thing will be triggering from the Hadoop.zar, and rest everything will be done automatically for you. So we have written just two pieces of code, mapper code, where I'm just splitting or producing my intended key and value pair. Reducer, I'm just summing up those intended values and producing the output. And this is the way I can give a name to a job. So we will talk all these things in detail. So in the Java world, let me quickly share the Eclipse part, and I'll just try to run it quickly. So in the Java world, the Mapreduce code looks something like this. So this is the mapper function which I was showing to you. This is the mapper class word count mapper, and here I'm just splitting that value into each word and producing the word comma 1. One is a numeric thing which I've created an object over here. And in the reducer part, this is my reducer, word count reducer, and I'm just summing up those values which are coming for each key. I'm sure that for Apple all the values will be available in this values object, and that is the beauty of in between short and suffer-fail. And after that, I'm just configuring all these things in my main class. And so here I'm setting the mapper class, setting the reducer class, and submitting the job. So how to run it? Again, the command is written over here for you. If you don't want to create it, goes into the complexity of running, compiling it and doing all those things. All you have to do is, if you don't want to compile even these programs or don't want to do anything, related to Java, when I'll be sharing this code folder, there is something called Mapreduce snapshot.zar. So this jar has all the program which I'm discussing with you people, and which I'll be keep on discussing with you people. So you can just directly move this jar to your Unix world and can run these commands directly, into Hadoop. Once you move on the jar, you don't have to do any all of these steps which I was doing previously, showing you to how to export the jar. So this jar is there in my Unix world. So now I'll go back to the Unix world. I'll just copy this command also. So Hadoop jar name, the fully qualified class name, input directory and output directory. So I'll just go to my this thing putty. So here, if I say, see this is the jar which is lying over here. So I just given command Hadoop jar name, fully qualified class name which I want to run, the word count Java file, and the input directory. That is this, and output directory. So I'll just cross check whether this input and output directory lying in my HDFS word or not. So for that, all I have to do is just go to a Hue browser. So, and we'll just cross check the input and output path. I'm just cross checking that in a minute. UDB input text.text. So there's a file called text.text in my input directory. And I'll ensure that output directory does not exist, because Mapreduce assumes that if the directory is existing, then it will not override the directory, and assume that you previously have done some costly task, and that output should not be deleted for you. So this is output directory, and I'm just trying to delete it from the Hue UI. I have not shared the screen. I'm just deleting it directly. So that directory is delete. So now all I have to do is I have to just give this command Hadoop jar name and input and output path, and press enter, and it will trigger a Mapreduce program for me. I'll show you on the UI also. So I can browse the currently running programs over here, job browser. So it will come in a minute. So it will come over in some time over here. So see, this word count came over here. The word count was the name I gave to this program, and its status is accepted. As soon as it processes, it keeps on increasing its percentages, and when it's done, it will say completed. So this is the job browser UI where I can browse the jobs. So I'll go to the console pack. So this job is submitted, and in some time it will produce an output to the output directory, and we'll just look into the output. So by the time it's running, any questions on today's session, and we'll go into the complexity of MapReduce part further on in our next session.
So where is the result displayed?
Result would be produced in the output directory,
where is the result displayed?
Result would be
okay. So we have to clean that file, right?
So yeah, will be placed in this directory, and then we'll open this directory and see the result.
Okay.
And so yesterday someone was asking whether a separate JVM will be created each time, or probably I think from your batch only. So if that based on different parameters, one of these parameters is upper mode. I'll talk about this thing in detail when I'm talking about the yarn part. Probably each time a new JVM might not be created, that might not be taken based on few optimizations automatically taken care by Hadoop for you. So see, it says it's all done. It produces all the statistics also about the job, number of bytes read, and things like that. So let's look into that Hadoop file. So all I have to do is Hadoop fs -ls/user/dp/u/dp/output was the path I gave for output directory. So if you look into this directory, there will be a file by name of PUT.
Output is wrong.
Yeah. So this file signifies there is only one such file which says part R000. This file signifies as our program was very small. So only one reducer was created for this whole program, and this reducer taken care of all the program. For bigger programs, automatically Hadoop takes care of how many reducers need to be created. You don't have to configure them. But if you require for different things, you can always change them. These are again configurable things. We'll talk about them. So let's look into this file. Hadoop fs -cat, and I'll get this file. So see, for each word it produces an count. So u was frequently used word, so it produces an count for u, 33 u comma. So the words are separated by space. In this program you can do all the logic to remove these special characters and things like that. And this is how the word count does work. And see, all the words are sorted. So that's the beauty of in-between sort and shuffle page, that it sorts your data based on key, and as our key was word, this file is sorted by the words. Any questions, anything? I'll just unmute everyone. If anyone has any question, anything. Oh, sorry, I'll unmute everyone. If anyone has any question or anything. No questions? Sure then, let's have a nice week. Try to download those softwares, try to install them, try to play with them. I'll also be sharing the code with you. Try to play with them. In the next session, I'll help you also how to run that code on your local PCs if you are facing anything with that thing. And then we'll look into the advanced MapReduce part, and then I'll give you some hands-on exercise to run on MapReduce. Try to write a simple Java code. I'll try my best to not where you don't have to write anything in the Java file, but try to run it, and then we'll move on to HiveOutPick.
Okay. Thank you then.
Thank you.
Thank you very much.
Thank you. Bye-bye.
Bye-bye.
Thank you, Miraj.
Thank you.
Thank you so much.